All right, welcome back. This should be on about page 233 of your workbook. Today we're going to do the second part of solving trigonometric equations. This time they're going to be nonlinear. In yesterday's lesson, we just went through solving equations that ended up being usually kind of simple. Cos theta is equal to something, sine theta is equal to something, and you were able to solve for cosine or sine. This is going to be getting a little bit trickier about what this looks like. And so we're going to take some of our algebraic strategies that we've developed over the last couple of years of how to solve some of these sorts of things. So that's going to be what we're doing here. It starts off with a little bit of review of some things that we've seen before with respect to that. And so here we go. We need to turn this around. And here we go. Solving for 4 sine theta is equal to cosecant theta. Our domain goes from negative 2 pi to 2 pi. So that's going to drive what our solutions are, how many solutions we have. And so here we go. 4 sine theta is equal to cosecant theta. And our domain goes from negative 2 pi less or equal to theta less than positive 2 pi, less or equal to, I believe, yeah, okay. So it includes positive negative 2 pi as endpoints that we could have solutions from possibly. Okay, so here this is in sine, this one is in cosecant, kind of handy here in that the reciprocal of cosecant is sine theta, so we're just going to turn those into the same trig function, multiplying both sides by sine. Now remember, we've seen this a little bit before. When we have sine theta times sine theta, or that means sine theta squared, we typically don't write it like this because that sometimes can be confusing depending on our brackets of whether we mean this or whether we are wanting to square your angle. Actually, this typically we don't do very often, but regardless, because of that, we get rid of the uncertainty about this by calling this 4 times sine, and then sine, we have the 2 for squaring right after the sine before our angle, in this case theta, and so we call it 4 sine squared theta, which means 4 sine theta times sine theta. We're not squaring 4, we're not squaring the theta, it's sine theta times sine theta. Our next step is going to be, well, we can do this one of 2 ways. We can do this one of 2 ways. We can divide both sides by 4 and then square root both sides. This will just be sine theta. This will be 1/2 when we square root 1 over 4, but remember, it's got to be plus or minus. When we are looking at that, sine is equal to plus or minus 1/2. Remember that sine is your vertical, and so its short side is vertical, and so it's going to be this. It's going to be the 30 degree or the pi 6 radians reference angle. It's going to be positive 1/2, so it's one of those two. It's also going to be negative 1/2, so it's also going to be those two in quadrants 3 and 4. So we have all 4 quadrants with the pi 6 radians. Let's just double check. Yes, this question said it gave us a domain that's in radians, so let's answer this question in radians, and so therefore theta is equal to, let's get our solution set, and we're going to list all 4 of these. All 4 of these starts with pi over 6, 5 pi over 6, 7 pi over 6, and our last one all the way around to 11 pi over 6. Ends up being the rest of our solution for this one. We could have gone about this a different way. 4 sine squared theta is equal to 1. We could have gone to 4 sine squared theta minus 1 equals 0, subtracting 1 from both sides. This is now a difference of squares, so it could have given us 2 sine theta plus 1, 2 sine theta minus 1, equals 0. And from here, we're going to get sine theta is equal to -1/2, sine theta is equal to +1/2, and we're still going to end up getting to the same solution either way. Number 2. Number 2 looks like cosecant theta is equal to -1.57. It gives us a domain of 0 less than theta less or equal to 2 pi. The other thing that this question does a little differently is it's telling us give solutions to the nearest tenth of a radian. So if it's asking to a tenth of a radian, there's your clue that you're going to be jumping into your calculator to do this. This is not going to be an exact value solution. Some of you that are kind of a little more astute are going to recognize that 1.57 is half of pi, but regardless, that's not what this is looking for. It's asking us, it's prompting us for decimals, and so we are going to jump into our calculator to do this. Cosecant theta is equal to -1.57, therefore 1 over sine theta is equal to -1.57. Multiply both sides by sine theta, divide both sides by -1.57. We end up with sine theta is equal to one over -1.57. Our next step, remember, is going to be sine inverse of this, but we're going to take the positive one. Why are we going to take the positive one? Because this ends up being equal to theta r. If we always look for the positive one, it's not going to mess around with us. We are going to apply the quadrants that we get. Sine needs to be negative, so we know that it's going to go down to quadrants 3 and 4. We jump into our calculator and you get theta r is equal to 0.69. We apply the fact that we have quadrants 3 and 4 because sine is negative. And what do we end up with? So 0.69 in quadrant 3. If that's your reference angle, keep in mind, if that's your reference angle, we have to add that to pi. So pi is going to be here, it's going to be 3.14159. We're going to add 0.69 to it. So our theta ends up being, we end up with two solutions. Our first one is pi plus 0.69. Our second one, if we're listing them, quadrant 4. Think about it, thinking about what happens in quadrant 4. Quadrant 4, we would go all the way around to 2 pi, and then we would back it up to get this, to get to our coterminal angle. How much do we back that up? Well, we back that up by, we subtract this reference angle, 0.69. So our second answer is going to be 2 pi minus 0.69, and that's our solution set. Let's turn them both into decimal. It asks us to the nearest tenth of a radian, so we're looking for 1 decimal place, and so we get our two answers, 3.8, 5.6, if we are rounding correctly. All right, so we have a box that we need to kind of fill in the blanks here. Let's think about what this ends up being. A nonlinear equation is when the degree is blank equal to 1. In 20-1, when we had an equation that was degree 2 or larger, we typically attempted to do what to it? Okay, so to fill in these blanks, we have a degree that is not equal to 1. So we have something that's either quadratic or cubic or whatnot. Probably won't see anything that monumentous in this, but it is not equal to 1 if it's not linear. Our strategy with this kind of stuff that we started with in 20-1, and we've done some more of it this semester, is we're going to first attempt to factor here. Same idea, just with trig ratios. Next question ends up being, okay, so no big deal, a little bit of review. If we have something nice and simple, x squared plus 4x minus 5 equals 0. So super simple. Two numbers that multiply to -5, add to +4. Remember, our step with this and our process with this is we broke this into its two little micro equations. We broke this into, and we don't really do this step anymore. This is x plus 5 is equal to 0, therefore x equal to -5. From here, we get x minus 1 is equal to 0, therefore x equal to +1, and we would write solution set -5, comma, 1, close your curly brackets, and that was it. However, we also need to look at factoring that ends up being non-monic trinomials. So when we have a coefficient other than 1, if we have got 2x squared plus x minus 1 equals 0, we need to be able to factor these. And I don't really care how you get there with factoring. Lots of people do this by inspection. There's different methods of factoring trinomials, whether you use decomposition or the cross method or whatever it ends up being, whatever works best for you. I look at this and I think, okay, two numbers that multiply to x squared, it's got to be 2x and 1x. That's the only way we can multiply to 2x squared. Look at this, this has got to be 1 on the end, the back end's got to be +1 and -1. We don't know which one is which, but the outside and the inside have to add to +1x. So this has got to be +2 on the outside, it's got to be -1 on the inside, and that's really all this is. X ends up being 1/2 from here, -1 from there. That's it. So just a little bit of review of non-monic trinomials. This is all relevant now. Because now we're going to do this kind of stuff with trig. It looks a little nasty. It looks, there's a lot more going on in here. However, it's really not that bad. If we look at this one, sine squared theta minus 2 sine theta minus 3 equals 0. We have a domain on here. That theta is going to be between 0 to 360, including those endpoints because it's less or equal to signs for both of those. This ends up being our clue that we're working in degrees, so we're going to give answers that are in degrees, not in radians. It's asking for us state the following on the given domain and state the general solution. Leave all answers as exact values. So we are going to get answers from 0 to 360, but also remember that it's asking for a general solution in here as well. Sine theta minus 3. So just like factoring with x, nothing really different here. We just have sine thetas in the front, two numbers that multiply to -3 and add to -2. Sine theta minus 3. Sine theta plus 1 is equal to 0. We come to two solutions again. Well, we come to two microequations. We're going to break this one out, and this tells us that sine theta is equal to 3. Let's come back to that in just a second. This one tells us that sine theta is equal to -1. Now, what do we know about sine and of cosine? Is it looked like this. If we didn't have any stretch applied to this or anything else going on with this, this has a maximum height of 1 and a minimum of -1. That tells us that sine has to exist. The value of sine theta is going to be between -1 and +1. It can't be more, it can't be less. If you try to type this into your calculator and do sine inverse of 3, it gives you an error. This is why. We can't have sine theta is equal to 3. If we think about it for a second, and sine is opposite over hypotenuse. If sine theta is equal to 3, that means it's opposite over hypotenuse ratio. That means the opposite is 3 times as long as the hypotenuse. Can that happen? No, it can't. Opposite hypotenuse, by definition, is the longest side of a right triangle. So this cannot happen. We have no solutions from this, and we just state no solution. Don't call it extraneous. Technically, that's not right. An extraneous answer is when we have found a solution that's either extraneous because it's a phantom answer that we've created with squaring, or more often what happens is it ends up being extraneous because of the context. So this is not extraneous, it's no solution, and we just leave it right there. Sine theta is equal to -1. We think about this. -1 is down here. There's our solution. So theta ends up being equal to, from this one we've got 270 degrees. And that's your only answer. Now that's your only answer if we're asking for answers from 0 to 360. If you're also asked for, like we are in this case, for a general solution, we would state it like this. So we have, if we've got this domain, we've got 270. If we want to make a general solution for that, remember that would account for 270 degrees plus the next one around, plus the next one around. Also -1s if we back it up. So we would call it 270 plus n times 360. We need degree symbols on here. And so this just tells us that we're adding multiples of 360 degrees. We want to state that n is an integer, whether you're using I or Z. We have to state that n ends up being an integer. You can have positive, negative, whole number multiples of 360 and still be coterminal with that 270, and that would give you all of your solutions. All right. Next page, just a few more questions left. And here we go, 4 sine squared theta minus 3 is equal to, nope, not theta, 0. So we've got 4 sine squared theta minus 3 equals 0 for theta's got to be between 0 and up to, but not including 2 pi. So there ends up being our domain. So same kind of strategy that we've been doing for years. Add 3 to both sides, divide both sides by 4. Gives us sine squared is 3/4. Our next step is, of course, to square root both sides. Sine theta is equal to, don't forget about plus minus. And when we do square root of 3/4, that is plus or minus root 3 over 2. So sine theta is equal to plus or minus root 3 halves. We know that number from our special triangles. That's the long side of a 30, 60, 90 triangle. And so we have, our triangle looks like this. It's the standing up of the 36, 90 triangle. It's the long side because it's the sine, and so it's that one. It's positive, so it's those two. It's also negative, it's all of these. So it's those two as well. If we're listing our exact value solutions, these are the 60 degrees, they are pi thirds. So pi thirds reference angle, so what do we have? We've got pi thirds in quadrant 1, quadrant 2 is 2 pi thirds. We skip over 3 pi thirds, that's right here. Here down here is 4 pi thirds and 5 pi thirds. That ends up being a list of all of them. And we're done. It does state to give the general solution as well. So if this was not given in the question, what would the general solution look like? The general solution is kind of interesting with this. Because the general solution, we could create 4 general solutions and call this pi thirds plus 2 pi thirds plus 2 pi times n, 4 pi thirds plus 2 pi. So we could list them all just and have 4 general solutions like this. We can actually save some steps though, because if we list pi thirds, this isn't going to work just to add another pi thirds, but if we do add pi to it, we come all the way around to this solution down here. And if I add pi to that, then that brings me back up to this one. So my general solution, we can actually write it just in 2. We can say theta is equal to pi thirds plus n times pi, where n is an integer. So that's going to account for the one in quadrant 1 and quadrant 3. We could also list 2 pi thirds For the other ones, that's going to count for quadrant 2 and quadrant 4. If I add multiples of pi, we're going to get both of those. And so that ends up being my general solution, is those two general solutions. That's what it ends up being. Question number 5. Cos squared theta minus cos theta equals 0. Now, be careful about this. What we can't do is you can't divide both sides by cos. You're going to lose solutions potentially, and so dividing both sides by cos, you're thinking, oh, this will just be cos minus 1. No, 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 no. First step is going to be to factor this. So cos theta minus 1 equals 0. There's our correct first step. We do that. Now we break this apart into cos theta is equal to 0 for over here. Over this one, this is going to be cos theta is equal to positive 1. Super simple. Where is cosine 0? Cosine is 0. Cosine is your left and right, so it's 0 at pi halves and at 3 pi halves. Cosine theta is equal to 1. That's our first list of theta. Our second list of theta, cosine theta is equal to 1. That happens here, right? That happens at 0 degrees and at, let's work in radians. 0 radians and at 2 pi. So we do have 0 as an answer. It does tell us on our restrictions for this one, we are working in radians from 0 to 360. It did include 360. It did say in the question, 0 is less than theta is less or equal to 360. That less or equal to part is relevant now because that's going to be included as an answer. So 0 degrees and 360 degrees. Let me change this one. That was a mess up. What do we have here? Instead, we have, let's call this 90 degrees and 270 degrees. So our specific solution to this for that domain is going to be 0, 90, 270, 360. We would need 2 general solutions. One for this one, that would say 90 degrees plus n times 180, and that would give us both of those. We would have this, and we would have 0 degrees plus n times 360, and that would give us that point over there all along. So if we didn't have a domain and we were just being asked for general solution, that's what that would look like. Do you want me to write that out? Sure, let's just write that out quickly. Theta is equal to 90 plus n times 180 for the top and bottom quadrantal angles. N is an integer, of course, almost always. And then this one is just going to be 0 plus n times 360. So we don't even really need the 0 on there. And that will give us all those if we were asked to do this without a specific domain. Next question, we're almost there. Question number 6. 2 cos theta, 2 cos squared theta is equal to 3 cos theta minus 1. Our domain goes from 0 to 2 pi, not including 2 pi. Oh, that's a little bit off here, off the screen, but that's okay. You've got it. Okay, so again, we need to factor this. 2 cos squared theta minus 3 cos theta plus 1 equals 0. We set this up as a trinomial. We get it equal to 0. This has got to be 2 cos theta and cos theta. That's the only way that we multiply that. 2 cos squared. We have to have negative 1 and negative 1 because we have to multiply the positive 1, and we're going to add them to negative 3 cos theta. That's going to be it. From here, we get 2 cos theta minus 1 equals 0. Cos theta is equal to positive 1/2. From this one, we get cosine theta is equal to positive 1. And so where are our points on here? Where's cos squared equal to positive half? Or sorry, cos theta is equal to positive half. Cosine is the left and right. It's the short side of our pi thirds of our 30, 60, 90 triangle. And so it ends up being the standing up version. It's pi thirds. So our solution from the equation number 1 is pi thirds. We also have down here, this is 5 pi thirds. For theta 2, cosine is equal to 1 at 0. In this case, it doesn't include 2 pi because it wasn't equal to 2 pi. If you look closely at your domain, the domain was 0 is less than theta is strictly less than 2 pi, but it was less or equal to 0. So 0 is included, yes. 2 pi is included, no. And so therefore, if I list all of this, therefore my solution ends up being 0 pi thirds, 5 pi thirds. And that's it. Last one. Question number 7. We have 10 to the 8 theta minus 10, 4 theta is equal to 0. For 0, less than theta is less than or equal to 2 pi. If we common factor here, we have tan 4 theta times tan 4 theta minus 1 equals 0. So just common factoring 10 to the 4. This we can factor further. So this is times tan squared theta plus 1 tan squared theta minus 1 is equal to 0. We end up with tan 4 theta. This doesn't factor any further because it's a sum of squares, but this difference of squares does. This is tan theta plus 1 tan theta minus 1 equals 0. Wow, so lots going on in here. If this one's just equal to 0, therefore tan theta is equal to 0 from this. This one gives us tan squared theta is equal to -1, which we'll have no solutions for, right? Because tan squared is equal to a negative. But from these two, we have tan theta is equal to plus or minus 1. So this we have a solution for. This we have no solution for. This we're going to have some solutions for. Where is tan theta equal to 0? Remember the tangent. This is your y over your x. So if it's equal to 0, that means y is equal to 0. Where is y equal to 0? Here and here. Where y is equal to 0 is going to be at those 2 points. Where is tangent equal to plus or minus 1? It's equal to positive 1 in quadrants 1 and 3. It's equal to -1 in quadrants 2 and 4. These are on the 45s or on the pi quarters reference angles. And we're almost done. Theta equals, we've got 0 here, pi quarters for this one, 3 pi quarters. We've got pi for this over here. We've got down here, we've got 5 pi quarters. We have 7 pi quarters. And we are including 2 pi in our domain. So we have, that is our last one. So 0 pi quarters, 3 pi quarters, pi, 5 pi quarters, 7 pi quarters, 2 pi. That's our list of all of them. We do need to state restrictions when we have tangent. And so we do need to look at that. And perhaps that's going to, perhaps if we've got tan theta in here, that tan theta equals 0 and tan theta equals plus or minus 1. We do need to state restrictions on this. Remember, tangent is sine theta over cos theta. Tan theta is sine theta over cos theta. So we have, really comes down to this. What can't happen is we can't have cosine theta equaling 0. So we have a restriction on this, and our restriction is cos theta cannot equal 0. Where does that happen? That happens here and here. Cosine theta can't equal 0. Therefore, we do need to state in this question that theta cannot equal pi halves. It cannot equal 3 pi halves. If that restriction matched up with any of our solutions, therefore it would be, those would be extraneous. We would have to cut those out of our solutions, but we don't have that in this case. All 6 of these solutions are perfectly good, and we are done. Bottom of the page, couple last things. Hit number 1, if it's not factorable, you're going to have to solve it graphically. Hit number 2, if asked to solve for the nearest 10th or 100th, that's also going to be graphically. There's your clue that it's not going to be exact values if you're asked to the nearest 10th or 100th, and that's it. All right, any questions, please let me know. Please email me, and I'll be happy to help you with this. All right, thanks so much for watching.